Hey.
Hey.
Okay, look. Okay, so I've been dating Carbeni for almost a year now, right? And our anniversary's coming up. You're her best friend, Oxygeni. What do you think I should get her?
Carbeni.
Mm-hmm.
Maybe a carbon allotrope.
What's an allotrope?
Well, some elements exist in different physical forms, and these different physical forms are called allotropes.
An allotrope is kind of like an anagram. Think about the words listen and silent. They're both made of the exact same letters but arranged differently to create a completely different word.
So carbon exists in different forms?
Yeah.
What kind of different forms are there?
Let's start with coal.
Well, coal's chemical structure is mainly made of carbon, but it's also made of hydrogen, oxygen, nitrogen, and sulfur atoms, making it different from the other carbon allotropes. Coal is the most abundant fossil fuel on the planet. There are 4 different ranks of coal. There's peat, lignite, bituminous coal, and anthracite. So coal first forms as peat, which is mostly made of organic matter, usually from ferns and vegetation from swamps or bogs. Because of this, peat contains a lot of water, which limits the amount of energy it can absorb. Over time, with increasing pressures and temperatures, peat turns into lignite. Lignite is a soft brown coal that still contains a high amount of water. So bituminous coal is formed when more pressure is applied to lignite coal. Basically, if you haven't guessed, the more pressure applied, the more water leaves and the more pure carbon is present, which increases the heat content of the coal. Bituminous coal makes up about 52% of coal reserves and is the type of coal most commonly used. Anthracite coal is a metamorphic rock and is considered the highest grade coal. It's hard, dark, black in color, and is very lightweight when compared to other forms of coal since there is next to no water present. This coal only makes up 1% of all coal reserves. So coal is a very common energy source for heat and electricity. It is involved in electricity production, steel production, the cement industry, paper industry, aluminum industry, chemical and pharma industry, and also as transportation fuel. The extraction and burning of coal causes many environmental and health problems. As a result, the movement to limit the use of coal has been quite popular. Coal is associated with very high emissions of greenhouse gases and toxic pollutants. Of the 10 industrial faculties in Canada that emit the most greenhouse gases, 7 are coal plants. Coal burning plants emit high levels of sulfur dioxide, nitrogen oxides, and mercury. Coal miners are at risk of stroke, lung disease, black lung, asthma, and lung cancer. The substances emitted are connected to illnesses including bronchitis, pulmonary disease, and elevated rates of infant mortality. On top of that, surface mining destroys wildlife habitats, ecosystems, and causes harm to water systems through pollution, way more than underground mining. But the reason why surface mining has been more popular in the industrial world over underground mining is due to the reduced health hazards for workers. Due to these environmental and health concerns, provinces such as Nova Scotia, Ontario, Manitoba have been trying to limit their use of coal in the past 5 years. In the year 2000, approximately 26% of the province's electricity came from coal. That number declined to about 19% in 2007 and 8% in 2010. In April 2014, the last of these plants, including the Thunder Bay Generating Station, was shut down, making Ontario the first jurisdiction in North America to stop using coal as an electrical power source.
I don't like Carbeni, but want something so brown with so many health and environmental impacts.
Maybe graphite would be a good idea.
So graphite is the most common and stable form of carbon. The carbon atoms in graphite are linked sheets of connected hexagon shapes. These sheets of hexagon shapes are one on top of the other. They're poorly connected and easily slide over each other, similar to a deck of cards. There are 3 types of naturally occurring graphite. The first is crystalline flake graphite, which is isolated, flat, and is made of plate-like particles with hexagon edges. The second is amorphous graphite. Amorphous graphite is made of fine particles and is the result of thermal metamorphism of coal. This is sometimes called metaanthracite. Lump or vein graphite occurs in fissure veins or fractures, appears as growths of fibrous or acicular crystalline aggregates. So graphite is soft, greasy, slippery, grayish-black, has a metallic luster, is opaque to light, insoluble in water, and is a good conductor of electricity or heat. Graphite's major use is making lead pencils. The lead in pencils is a mixture of graphite and clay. It's also used in electrical lamp electrodes. It's used to make crucibles since it's resistant to chemicals and has a high melting point. Graphite is also used as a dry lubricant in machine parts since it's so slippery. and also in materials including ovens, lithium-ion batteries, and alkaline batteries. There are currently only 2 graphite mines in Canada, one in British Columbia and one in Quebec. But as the Chinese supply of graphite is being more and more restricted and demand is rising, mines are starting to reopen in southern parts of Ontario. Like coal mining, the popular way to extract graphite is through open pit mining, which gives coal and graphite mining many similar environmental impacts, including air pollution, soil contamination, destruction of ecosystems and habitats of different species. On top of that, the milling process of graphite uses harmful chemicals and is very wasteful. Workers involved in the mining and processing of graphite are at risk of graphite pneumoconiosis, which is when dust particles from the graphite remain in the lungs and in the body. Lungs diseased by graphite become discolored, turning gray or black, and could look like sponges that are full of ink.
She likes to draw, but she already has a bunch of graphite pencils. I don't think it would be that special.
Well, buckyballs is another carbon allotrope.
The discovery of buckyballs was all thanks to the man Buckminster Fuller. A laser was used to vaporize a graphite rod in a helium atmosphere. What began to take place was carbon molecules with C60 atoms were forming in a spherical shape. The chemical structure of buckyballs is often compared to the structure of a soccer ball. 60 carbon atoms bond together in hexagons and pentagons, where each atom is linked to 3 others in a covalent bond that come together in a sphere. The C60 model was found to be extrememely stable, is black but becomes red in petrol, is able to handle high temperatures and pressures, and although they do not bond to one another, they do however stick together. Buckyballs have been the subject of intense research because of their unique qualities and their technological applications, especially in materials science, electronics, and nanotechnology. Buckyballs or fullerenes are used as superconductors, lubricants, chemical sensors, as catalysts, polymer additives, and antioxidants. They also have many medical uses as pharmaceuticals, targeted cancer therapies, and optical devices. Not much was found when testing the toxicity of buckyballs, but some studies show that buckyballs can be easily absorbed into animal cells, showing how the molecules could potentially be toxic to humans and other organisms. Studies have also shown how they can invade cell membranes, cause brain damage in fish, and lung damage similar to that caused of asbestos.
You got anything else?
I think that's it.
Really? I feel like something's missing.
Are you questioning me?
No, of course I'm not questioning you.
Oh wait, there's diamonds!
Diamonds are not found on the surface of the Earth. Instead, they form at high temperatures and pressures 100 miles below Earth's surface. Most of the diamonds that have been discovered were delivered to Earth's surface by volcanic eruptions. These eruptions tear out pieces of mantle rock known as xenoliths and contain diamonds. The carbon atoms of a diamond are arranged in a cubic lattice structure. Each carbon atom in a diamond is covalently bonded to 4 other carbons in a tetrahedron, so there are no free electrons. Together, the tetrahedrons form a 3-dimensional network of 6-membered carbon rings. This stable network of covalent bonds is why diamond is so incredibly strong as a substance. So diamond has a high dispersion of light, high index of refraction, and high luster. It is also the hardest known natural substance. It has a high melting and boiling point. It is non-soluble in water and is not a good conductor. 80% of diamonds are used as a cutting tool and for other uses where durability is required. They are also used in grinding, polishing, and as semiconductors and microchips. Gem quality diamonds are the most perfect diamonds with minimum impurities and defects. Gemstone diamonds are sold for their beauty and quality in jewelry. 2 years ago, Canada was the 5th largest diamond producer in the world by volume and 3rd largest by value out of 21 countries. All diamonds mined and cut in the Northwest Territories of Canada are laser inscribed with a unique identification number so that retailers can assure they are conflict-free stones. All Canadian diamond mines are overseen by the Canada Mining Regulations for Northwest Territories. This program ensures the preservation of surrounding land and aquatic habitats. However, Canadian diamond mines are often built in environmentally fragile ecosystems, have extremely large ecological footprints, and have a huge impact on the caribou, wolverine, bears, and fish which provide food for Aboriginal peoples. 1,750 tons of earth has to be removed to find only a 1-carat diamond. Average engagement ring diamond size in 1920 was 0.3 carats, but today that has risen to 1.25 carats, and the demand continues to rise exponentially. Not to mention the 20 tons of mined waste produced to make 1 gold ring to hold a diamond. Gold is mixed with cyanide, a known toxic poison, to dissolve the gold or silver from the ore, making the land and waterways around the mining area poisoned.
I think that'll make a great gift. So it's anniversary of it.
Yeah, you're right. It is.
Happy anniversary, babe. My first place.
No, I don't care if you got first place.
Mints?
No, I don't want your stupid mints.
Here, open your wallet.
What type of gift is mint?
You abuse.
1-800-childabuse.com.
You should get her carbon allotrope. Wait.
Go.
What's all? What's?
Okay.
I want to get this done. I'm so stressed. I just like editing. I don't like this process.
What's an allotrope?
You didn't say this line.
Yeah.
Oh, you said oh. Oops.